Hello everyone, I am Jayant Vyas and I am presenting Drive BFR Driver Behavior and Fuel Efficiency Based Recommendation System, which is accepted for publications in IEEE Transactions on Computational Social System 2021. So nowadays we are having so many transportation companies for the ride sharing like Uber, Lyft, GrabCab, Ola, and they are providing so many employments for the drivers to take the rides. But the problems is occurs when the drivers takes the long hours of journey and there is no systems to monitor the driving hours of the drivers, and also not considering their driving behavior or stressed conditions or fuel efficiency. So for that we are presenting our systems, and our other motivation of these systems is the taxi the road deaths. Like we can see here that the in 2018 there are very high road deaths. Like we can see the reports of the Microsoft Power BI and the WHO, and the hour speeding is the main cause of the road deaths. So our contribution is the driver recommendation system using the VNet architecture, and we also use the vehicle telematics data instead of the physiological data. And our proposed model shows the better accuracy than the existing state-of-the-art models. And we also consider the fuel efficiency for the driver recommendation. So this is our proposed recommendation system. So you can see if a person, if he requests for a taxi ride, so the request goes to the cab companies and then it's forwarded to the nearest IRSU of the customer and then forwarded to the different cars based on their drivers behavior or fuel efficiency conditions. So this is the flowchart of the system. So first the request go to the company and then it is go to the nearest RSU and then it is go to the driver based on the his driving conditions and the fuel efficiency, and if the driver accept then it is go for the pickup, otherwise it is search RSU search the other suitable driver for the request. So in this methodology we first pre-process the dataset and then we used MTL MMI and HMM model for the driver fuel efficiency and the behavior identification, and then using multi-objective optimization we recommending the driver for the trip. So these are our pre-processing steps we followed in the for the dataset. Here is our multi-get mixture of experts MTL model. So the first is we made the changes in this, that we introduced the mixture of expert layer in this, and second one is the we added the gating networks. So you can see in this, so we added the embeddings here, and the second one is the gated network here in the MTL MMI. And for the fuel efficiency we use the HMM. So we use the different driving maneuvers like speed, slide, side slipping, fast U-turn and weaving. We gave the from the input we just identified this type of actions by the drivers, and then we identify the behavior of the driver. So this is the whole architecture or the block diagram of the whole recommendation systems. So first the trip data is fed into the MTL MMI and then HMM and then fuel efficiency and then the recommendation of the driver. So these are the drivers, participants and the vehicles used for the dataset collections in the UH driveset dataset. And these are the different parameters we identified like driving states and the speed of the vehicle, traffic condition, etc. from the dataset. These are the features we used in the experiments. So this is our results, like using regression techniques comparison based on the MSE, and this is for the R square. So these are the HMM accuracy in behavior score assigning based on the precision, recall and AUC. And this is the comparison with the different state of the art models which is using the physiological data, and this is the comparison with the systems for behavior classifications. This is our systems ROC curve which is giving the 95% of accuracy, and there can be different applications of the proposed systems, like it can be used for the training of the drivers or making a roster for the drivers that how they are working, or monitoring of the drivers also. These are the many challenges we are having still left and which has to be tackled. So the first is very important is like the availability of the datasets. There is very limited datasets available for this. So a dataset creation is also one task here. and also that the weather's effect on the driver behavior is also not tackled here in our case, so that is also can be checked in the future work. These are the references we used for our work. Thank you.